So if you've got questions for any of the speakers, note them down because you'll have more coming. We now move on to the cloud area with David Glazer.
Okay. We are in here somewhere.
Yeah, I think it might be that one. I don't know. Try both. This one.
Yeah. There we go. Great. All right. Thanks, Ewan. And I guess I have to stay. These live? Yeah, that one's live at least. So I'm David Glazer. My day job, I work at Verily Life Sciences, and I'm co-chair of the Cloud Workstream together with Brian O'Connor. Want to give you an update on the work we've been doing, where we're headed, and one of the new standards that you had mentioned that was just approved yesterday by the Global Alliance Steering Committee. So I can give you the Reader's Digest version of my talk. A year ago, we said we were going to do some stuff. We did it. Thank you. So the first 3 slides here are slides from a year ago this month in Orlando at the previous plenary, where we laid out the goals and the approach that we wanted to take towards moving towards taking full advantage of modern cloud tech in the world of biomedical data. And we were starting by saying, what can we do to facilitate taking people who have algorithms and tools and workflows and bringing those workflows to the data in the many places that data lives, but knowing you get compatible results independent of where your data is actually living. And to do that, we had a sketch of an architecture that said that we want to be able to define workflows in some standard way, package them up, and then hand them to workflow engines, where those workflow engines can live in many different places. There can be more than one implementation of the engine. But again, you can be confident that if I've built a particular workflow, I should be able to run that workflow wherever I want on whatever data I have and be confident I'll get the same answer. And therefore, our task as a work stream was to come up with the standards to facilitate the definition of these portable workflows, the sharing of them, and the execution of them. And again, hitting those blue text in the bottom bullet there again, the execution of those portable workflows in your preferred compute environment and your preferred storage environment. That's the point. That's the portability that we're looking for. So what we've done over the last year and where we are now is we have made a big dent in this by saying we have officially said that the Global Alliance supports the use of these 2 existing standards, CWL and WIDL, for actually how one defines a portable workflow and packages it up so that it can be put in a box and taken from where you are to where you want to run it. And the new, as of yesterday's standard, WES, the Workflow Execution Service for running these workflows. The things we're working on next to really declare full success on this vision are to publish the Tools API, lots of early work on that, and a Data Access API. So that's where we're going next. But what we have with the Workflow Execution Service really is the first big step in use across several of the driver projects and others. So the API is official. If you're interested, these are easier to find just from the Global Alliance site, but you can find the documentation on it. You can find the repository that has the actual API definition using OpenAPI, and the testbed that we've been using to show that this standard actually works across multiple environments. So again, why does this matter? The general goal is we want to be able to do that portable execution, one analysis, running in a lot of places. And what that will enable is the 2 sides of the people who are using tools and the people who are building tools will both get more reach and more power for what they need to get their job done. So if I'm a tool builder, if I'm someone who's created a new analysis method, I have a structural variant caller that I think in some domains is better than the state of the art, or I'd like to find out how it compares to others, it would sure be nice if I could package up that work once and then say, here it is to the community, and have any of you who want to try out my new structural variant caller be able to try it out in your environment, on your data, whether or not you're ever going to show me your data, whether or not you trust me at that level or not. you should be able to work with me on my tool. So as a tool builder, it lets me get a lot more reach and therefore a lot more value from my investment in tools. Well, as a researcher, as a consumer, in addition to giving me access to more tools, it means I now can run compatible analyses across data in many places. I talked to many of you about projects you're working on where I've got 1,000 genomes, or I've got 100,000 genomes, or I've got 1,000,000 genomes, and I would like to be able to do some common reasoning across those. The video highlighted one of many reasons why that matters. The first step in being able to do common reasoning across them is analyzing them the same way. So as we make it easy to take a workflow, take an analysis, and run it the same way in all these different environments with different policies and different physical environments, that increases the pool of available, compatible, and comparable results that we can work with. So that's why we want this ability for a tool builder to build their tool, have it run everywhere, and as a researcher, consume those results in a known, compatible way across. So how do we do this? Well, the documentation is online. I have 2 slides that are just excerpts of the highlights of the documentation about what the workflow execution service does. So this is the executive summary, which I've just gone through, and the features of the API are what you'd expect. The first and most important one is you can say, please run this workflow on this data. So it defines a standard way to say that. I want to run this tool, and here are the inputs. It lets you pass in parameters to the workflow to say, what are the, maybe I have a slightly different flavor of it. Maybe I want to use more compute resources or fewer. Maybe I want to tune the size of a sliding window somewhere in the analysis. So it lets a workflow be flexible that way if you want to. And then it lets you do the mechanical stuff you need to do, to the operational stuff, to actually check on a workflow that you've kicked off and see how it's going, cancel it if it gets stuck, troubleshoot it if there's a problem, confirm what's completed, like that. So technically, this is the complete surface area. The documentation goes into the inputs and outputs of each of these, but this is what the API looks like. There's a post method to say run a workflow, a few interrogation methods to check on how it's going, and then an opportunity to cancel a workflow and get some overall information about the service. Again, all the details are in the documentation, but it's pretty straightforward to the needs. Once we defined the standard and we started working with all the projects that we thought would want to use this, and all the people who had tools, the tool builders who we thought would want to use this, we wanted to make sure it would work together. So at the Global Alliance meeting 6 months ago, which was a working meeting of a bunch of the work streams, we laid out this vision for a test bed. And we said we wanted to create a test bed that would demonstrate that we not only had a theoretical way to have interoperable workflows, but we could confirm they actually worked. And the idea was we would build up a small set of representative workflows with known answers, where if I were building my hypothetical structural variant caller, I could say, and by the way, here's a test set of inputs, and if you successfully run it, you should get these outputs. So we'd build up a library of these test cases. We'd then build an orchestrator whose job would be to do the 3 steps in the top middle there of, say, run every test against every environment. And we'd get a list of the people who had implemented these WES endpoints, these implementations, and say, let's try each of our test cases on each of our endpoints and see how we do, see how it works. So that was the design 6 months ago, with a lot of help from James Eddy from Sage, who built the orchestrator. There's a link to it in the slides if you want to see the code he's using. This is as-built. We have workflows from a set of the driver projects that we've been working with that are representative of their real-life, day-to-day jobs. These are the things they need to do. And then we have 4 implementations that the testbed has been running against from a variety of organizations. One not quite planned, but it worked out really well, and I'm delighted. As you can see, that one of those implementations is running in the Azure cloud, one is running in the Amazon's cloud, one is running in Google's cloud. Illumina's, I'm not even sure which cloud it's running in, which is great. I think it's Amazon's, but it's nice that I don't need to know. So our span of implementations includes some different back-end code and some different runtime environments. And where we're at over a lot of different people collaborating to check the details and dot the I's is a lot of these green check boxes where we can see, hey, these workflows actually run across these different endpoints. And you can see, for example, on the top med workflow, I'm not going to try to do the laser here, but you can see on the top med workflow, pretty much in the middle, you can see a column there where that workflow successfully ran across all of the endpoints. Different ones had reasons why some implementations are particular, but a lot of green checkbox, which is what we were going for. Here's the slightly more readable version of that. The test workflows that we have came from a few of our driver projects and some other people who are lowercase drivers. As Ewan said, you don't have to be a driver project to contribute and add a lot of value here. And the kinds of workflows that they ran, the 4 organizations that built the test endpoints, and then we have other people who weren't part of the test bed but are actually using WES in the NIH Data Commons project and have done the same kind of interoperability within that environment as part of the development of that. So feeling pretty good about having some real world validation that these theoretical standards actually work, actually play together nicely the way they're supposed to. And building on that, what we intend to do over the next year are first around WES itself, support the adoption, work with all of you that we've talked to over the last bit, and others who are hearing about WES for the first time now, and say, how can we help you actually deploy this in your environment? Make sure that the implementations, when there are bug fixes in the corners, help address those. Improve the documentation. I think our documentation is barely adequate right now, and as people go to use it, you'll give us feedback on how we can make it better, and do that. And then we want to finish that Orlando vision by filling in those open to-dos around published standard for tools and a published standard for data, which complement the execution and pull all that together. We had a couple of great meetings of the cloud workstream, one yesterday afternoon, one this morning, here to really move that process forward, and we have a roadmap for how to do that. So hope to be here a year from now saying this with the same hopefully boring summary of, we told you what we were going to do, we did it, here's a picture. That's our intent, to do that again in a year. As always with these kinds of projects that are about interoperability and about connection, it takes an army, and we had a huge group of volunteers from a bunch of different organizations. I've listed the people who were most active most recently on this, but there are many other people who have been part of the cloud workstream over the last year or two in helping us define the right target and then build implementations that start to move that forward. So thank you very much. And with that, I think we are moving on to Alex. Is the piece of paper here accurate? Yeah.
That's great.
All right. Thank you.